All right. This is the video lesson for Thursday's lesson 7, solving systems with substitution, day 3. Okay, so again, we start off with solving a system graphically, which we know how to do. So our first equation is already in y equals mx plus b form, where our m is -2. We're going to write that as a fraction, so -2/1, which means we're going to be going down 2, right 1, and our b is 0. There is no y-intercept written, so you can think of it as +0 at the end. All right, so let's go ahead and graph that one. We're going to start at the origin, and then we're going to go down 2, right 1, down 2, right 1, because our slope is -2, up 2, left 1 to reverse it, connect, label, and arrows. This was born y equals -2x. All right, now let's graph the second linear equation. This one is not in y equals mx plus b form, so we need to move some terms around. I'm just going to rewrite it. We want to get the y by itself, so we're going to minus 6 on both sides, and then we'll end up with y equals x minus 6. This is in y equals mx plus b form now. I'm just going to box in both equations so we can clearly see it. Okay, so in our pink equation, our slope would be 1, right? There's a 1 there. Just put it in. Write it as a fraction, 1/1. That tells us we're going to go up 1, right 1. And our b is -6, so we're going to begin at -6 on the y-axis because this is the y-intercept. And then we're going to go up 1, right 1, up 1, right 1, circle the point when they intersect, which we found already. You can go down 1, left 1 as well. And this was the original equation was y plus 6 equals x. Okay, so the solution, the point of intersection is right here, which would be 2, -4. Right? It goes x, y. Okay, now how can we solve this system algebraically, right? That's what we've been doing the last 2 days. So to solve this system algebraically, I'm going to rewrite both equations. So we have y equals -2x, and then we have y plus 6 equals x. Okay, so we've been practicing plugging in from the expression from the first equation into the second one. So let's look at what we have here. We know that y equals -2x. So I can take that -2x and plug it in for y because -2x equals y. So instead of y, I can write -2x, and then I can bring down my +6 and my equals x. I'll even put in parentheses so you see that instead of our y, we're plugging in -2x. Now we have an equation with everything in x instead of x and y, so we can solve for x. So now we're going to solve for x. So I'm going to rewrite my equation. Right, so over here we plugged in. We plugged in -2x for y. That was our first step. Now our second step, we're going to solve for x. All right, so we have x's on both sides. We need to get them all on one side. So what I'm going to do is move the term with the x's on the left over to the right because we already have a constant on the left. I don't want to move this 1x because then we'll have nothing on the right and everything on the left. So even though it's a little bit backwards, I'm going just to put my 1x there. I'm going to move my x's over to the right. Now I'm left with 6 equals 3x. And then I can divide both sides by 3 and get that x equals 2. Now, for every solution, though, we need x, y. So we have to go back and find the y. So our third step is to plug in 2 for x and solve for y. So you can pick whichever equation you want. So I'm just going to pick the first one. y equals negative 2x. Let's plug in our 2 for x because we know that x is 2 now. And we'll figure out that y equals negative 4. So then our last step is to write your solution as x comma y. So our x is 2 and our y is negative 4. All right. So here are our steps. Find the equation that has a variable completely by itself on one side of the equal sign. Substitute the number or expression from this equation in for the variable that is equal to in the second equation so that a linear equation in only one type of variable is created. Then you solve for the given variable. Then you substitute your answer back into one of the originals. And then you write your solution as x comma y. And then we can check it as well. Okay. So we're looking for the equation with a variable by itself. So here we have a variable by itself on the first equation. The y is by itself. It says y equals 2x. So we can take that 2x and plug it in for y. So instead of a y there, we're going to have a 2x. I'm just writing it in parentheses so you can see that I'm plugging in that 2x for y. All right, now we can solve. So we have an x, this is a 1x and a 2x. We can combine those and get 3x equals 15. Divide both sides by 3. We know x is 5. Okay, but now we need to go back and we need to solve and figure out what the y is because it's not good enough to just have the x. So let's go back to our original equations. I'm going to choose the first one, which is y equals 2x. And I'm going to plug in my 5 for x and then evaluate. 2 times 5 is 10, so now we know that the y is 10. So x is 5, y is 10. Let's write our solution as 5 comma 10, right? Because it goes x comma y. And there's a nice spot actually down here for our solution. All right, so our first step was to find the equation and substitute that in. Our second step was to solve for x. Our third step was to substitute in our x that we found to figure out what y was. And then our last step was to write our answer as an ordered pair. Our fifth step is to check it. To check it, you can rewrite both equations. Plug in your 5 for x and your 10 wherever you see a y. So again, 5 for x, 10 for y. And then let's check and see if these balance. 2 times 5 is 10. 5 plus 10 is 15. So both equations check. That means that that point is on both lines. All right, let's try number 2. We're going to take this negative 3x that it says y equals because the y is by itself, so that's the one we're looking for. And we're going to plug that in for y in the second equation. Right, so that is step 1. Step 2 is to actually plug it in, and let's see what our new equation is, and then we'll solve it. So 2 times y minus 5x equals negative 22. Well, we said that y was negative 3x, so let's plug that in. Now we can solve. I'm going to draw my line down my equal sign, and let's see what's going on here. Well, we need to multiply this first. So 2 times negative 3x is negative 6x minus 5x equals negative 22. We can combine like terms on this side, negative 6x minus 5x. We can combine that. So negative 6 minus 5, or I'll even circle them because they're like terms, would be negative 11x. Now we can solve for x by dividing both sides by negative 11. And we will get that x equals positive 2. Okay, now we have to go back and solve for y. So we can pick whichever equation we want. I'm going to just pick the first one here where it says y equals negative 3x. And I'm going to plug in my 2 for x that we figured out it was and figure out what y is. Negative 3 times 2 is negative 6, so that means our y is negative 6. And then step 4 is to write your solution as x comma y. So that would be 2 comma negative 6. And then the fifth step would be to plug those both in and check, which you can do on your own. Okay, let's look at the next one. So this is number 3. We have 3, 4, 5, and 6. Oh, and 7 and 8. Oh my goodness, lots. Okay. So for this one, the x is by itself. So we're going to box in our 4y. We know that equals x, so we can plug that in for x in the second equation. So I have y plus 4y equals negative 10 instead of y plus x. This is just the same thing as 1y. We can combine these like terms. 1y plus 4y is 5y. Divide both sides by 5 to get y by itself, and we figured out that y was negative 2. Now we can figure out what x is. Go back to the originals and plug in negative 2 for y. So I'm just going to start with the first equation. That one looks easier to me. I know that my y is negative 2. So let's plug that in and solve for x. 4 times negative 2 is negative 8. So that means that x is negative 8, and our solution is negative 8, negative 2. Okay, for number 4, they're telling us that the x equals negative 3y. So x is by itself, so we're going to work with that one. So we're going to take that negative 3y and plug that in for x. So this would be 2 times negative 3y, right? Instead of x, we're writing negative 3y. Plus 8y equals 14. Now we need to solve for y. We can multiply these two together and get negative 6y. We can combine these like terms. Negative 6 plus 8 is 2, so 2y equals 14. And then we can divide both sides by 2 to figure out that y is 7. Now I can take that value of 7 for y and plug it back into one of the originals. I'm going to go back to the first equation, plug in that 7 wherever I see a y, and figure out what x is. Negative 3 times 7 is negative 21. So that means our x value is negative 21, and our y value is 7, making our solution x comma y, negative 21 comma 7. Okay, for number 5. All right, so number 5 is a little bit harder. The y is by itself in the first equation, so that's the one you're going to look for. We're going to take this 2x plus 3. That equals y, so we can plug that in for y. So I have x plus whatever y is equals 9. Well, y is 2x plus 3, so we're going to plug that in. And then we will simplify from there. I'm just going to rewrite it without parentheses to make it easier to combine like terms. Okay, I can combine my 1x with my positive 2x and get 3x plus 3 equals 9. Now I can solve for x by minusing 3 on both sides. That would be 3x equals 6. Divide by 3 on both sides, and we figured out that x is 2. Okay, so now I can take that x is 2 and plug it back into one of the originals to figure out what y is. I think the second one's going to be easier for this, so I'm going to rewrite x plus y equals 9. My second equation, plug in my 2 for x, and then figure out what y is. I'm going to have to minus 2 on both sides. 9 minus 2 is 7, so y equals 7. So our solution is 2 comma 7. And again, you can check by plugging that back in. Plug in the 2 wherever you see an x, a 7 where you see y, and see right away you'd see 2 plus 7 is 9. And then for this one, 2 times 2 plus 3 is going to give you, let's see, 2 times 2 is 4, 4 plus 3 is 7, so it gives you that 7. So you can definitely check them. Okay, number 6, we're looking for one that's by itself, so a variable that's by itself. So the y is by itself. So I'm going to take that 2x minus 11 and plug it in for the y. So my second equation, I'm going to rewrite it as x minus whatever y is. So 2x minus 11 equals 3. Okay, this one's a little tricky. See this minus sign? We're minusing the entire y. So this entire 2x minus 11 needs to have that minus sign. So we're going to treat this like a -1 and distribute it. So now I'm going to have x minus 2x, because -1 times 2 is -2. So x minus 2x, and then -1 times -11 is positive 11 equals 3. Now we can combine like terms. This is 1x, this is minus 2x. That's going to give us -1x. 1 minus 2 is -1. And then we just solve our two-step equation. Minus 11 on both sides. That'd be what, -8. Divide by -1. X is 8. Now I'm going to take that x is 8 and plug it back into one of the originals to figure out what y is. I think the first one's going to be easier because the y is already by itself. So y equals 2x minus 11. Let's plug in for x. Well, we said that x was 8, so we can plug that in right there and then figure out what y is. So 2 times 8 is 16. 16 minus 11 is 5. So our solution x comma y would be 8 comma 5. This one was a little bit tricky. Maybe I wasn't so sure what was going on with this minus sign, so I'm going to check this one. Right, so this should be the thought process. If this one was a little harder for you, maybe you got confused with that minus sign there with the distributing, we can check it. Rewrite both equations. So y equals 2x minus 11, and then x minus y equals 3. Plug in 5 for y. Plug in 8 for x. Again, 8 for x, 5 for y, and let's see if it checks. Does 5 equal 2 times 8 minus 11? Well, 2 times 8 is 16, and 16 minus 11 is 5. Check. 8 minus 5 is 3, so 3 equals 3. It checks. So we can confirm that what was going on with that minus, that whole expression, we did it correctly. Okay, 2 more. Okay, x minus 5y equals -96, and then y equals 3x minus 6. Look for where the variable's by itself. Our y is by itself here, so we're going to take the expression 3x minus 6 and plug that in for y. So I'm going to rewrite my first equation now. So we had, well, let me just rewrite it. So x minus 5y equals -96. X minus 5 times whatever y is equals -96. So we said that y was 3x minus 6. So we're going to plug that in for y right here. Now we have to distribute again. Just using all the colors. Okay. This minus 5 is like a -5, so we have to distribute this -5 to everything inside the parentheses. So we're going to have x minus a 15x, because -5 times 3 is -15, so -15x. And then -5 times -6 would be a positive 30. Bring down equals -96. Okay, now we can solve for x. This is a 1x. We can combine that with a -15x and get -14x, right? Because 1 minus 15 is -14. Now we can minus 30 on both sides. -96 minus 30. Let's see if I can do that in my head. That's going to be 9, 10, 11, 12, -126. Divide both sides by -14. I know it's going to be positive, but I don't know what 126 divided by 14 is. It's 9. I don't know my 14 times tables. All right. X is 9. Now let's go back and figure out what y is. Okay, so I'm going to rewrite whichever equation I think is easier to work with. The second one has the y by itself already, so let's use that one. So y equals 3x minus 6. And we know that x is 9. So wherever you see an x, you can put 9. And then let's just figure out what y is. So 3 times 9 is 27. 27 minus 6 is going to give us 21. So our point is x comma y, 9 comma 21 for our solution. So blurry. Okay, last one. All right, let's look for where our y is by itself. In our first equation, the y is by itself. So we're going to take the expression negative 2x plus 6 and plug that in where we see y in the second equation. So we have 8x plus 4 times whatever y is equals 24. So we're going to plug in negative 2x plus 6 in for y. All right, we're going to have to distribute again. This positive 4 needs to be multiplied by everything inside the parentheses. So we have 8x. 4 times negative 2 is negative 8x. 4 times positive 6 is positive 24. All right, now let's combine like terms on the same side of the equal sign. 8x minus 8x. Oh boy, well 8 minus 8 is 0, so this is 0x, which means just nothing, right? 0x. I mean, I'll write it. But 0 times anything is just 0. So we're left with 24 equals 24. Oh boy, do you guys remember what happens when you get a true statement like that? 24 will always equal 24. So what that means is infinitely many solutions. So that means that these two equations were actually equal to each other. They were exactly the same. And I can prove it to you. So this was our first equation. And then let's look at our second equation. If we rearrange the second equation, it should look exactly like the first equation, because when they're infinitely many solutions, they're the same line. So let's try and rewrite this in y equals mx plus b form. We have to get the y by itself. So I'm going to move this 8x over. Then I'm left with 4y equals negative 8x plus 24. I'm just putting the term with the x in front because it's y equals mx plus b. Then let's divide everything by 4. Negative 8 divided by 4 is negative 2x. 24 divided by 4 is 6. And would you look at that? They're the same line. Ha, did you get tricked? Didn't know they were the same line when you first looked at them. Second one looked crazy. Moved things around, we got the same line, infinitely many solutions. You did not have to do all this work in pink. After you plugged it in and you got like 24 equals 24, you should have known it was infinite, and then you could be done. All right, bye.